for the night. Okay. How would you find a simplified solution if there are multiple angles like 3x in the trig function arguments of your equation? I have an example attached where there are 3 different solution sets, but when you actually start writing out individual solutions, I noticed that really the more simplified solution set out would be x equals pi over 6 plus 2 pi n. So is there a way to know that this is a simplified solution set without having to annoyingly write out all the individual solutions and trying to find a pattern between them? I don't know. I don't know if there's a tip or a advanced way to be able to do this. I'll work through this problem and just kind of show you the way that I taught it and the way I've done it. And if anybody wants to comment down below of a better way, then let me know how to do it. So the way that I approach this problem is, well, so first of all, we forget about the triple angles. I don't care about the triple angles, right? And for a lot of students that even struggle with math, sometimes I would even say, you know what? Even if you don't like the trig, like let's just break this down into a 2x squared minus x minus 1, right? That is the factored form in terms of that without the signs going on, right? So forget about the triple angles, forget about the trig. If you were to rewrite this in terms of x's, this is what it looked like. Now, can we factor this? Now, hopefully you recognize this is not a hard factoring problem, right? If you were to break this down in terms of factored form, it would be a 2x here and have to be an x. Now, there's only 2 numbers that multiply to give you -1, right? -1 and +1. So which one goes which? Well, I know that since my middle term is negative, I want my 2x to be multiplied by the -1. And then, so therefore, this one has to be a +1. And again, let's just double check. 2x times x is 2x squared. Good. 1 times -1 is -1. Good. And does your inner and your outer add to give you -x? Well, 2 times -1 is -2x. 1 times x is x. -2x plus 1x is going to be a -x. Voila, we're good, right? Okay. So we got that. That's going to be the factored form. And the reason why that's important is because the first thing you got to do is factor this out. And again, don't worry about the triple angles for right now. Still, you can just factor things out. Like, remember, this is your x. If you want to use substitution, you can. Like, let u or x represent 3 theta to help you. A great technique you can use. But this factored form is going to be a 2 sine of 3 theta minus +1 times a sine of 3 theta minus 1 is equal to 0, right? So again, once you know that you have a product equal to 0, you can apply the 0 product property. So I have a 2 sine of 3 theta plus 1 equals 0, and I have a sine of, and I have a sine of 3 theta minus 1 equals 0. So now use your inverse operations to isolate the trig function. So I'll subtract 1 divided by 2. So I have a sine of 3 theta equals to a -1/2. And over here, I have a sine of 3 theta, not 30, it's 3 theta. Sine of 3 theta is equal to a +1. Okay, now to get to the theta though, I need to undo the sign. And to undo the sign, I got to find the values of sine that coincide with the -1/2 and the +1. So I'm going to go to my handy dandy unit circle. And yes, I have my unit circle memorized decently. So I'm going to spit out these values rather quickly, not spend too much time. Expect that if you're doing these types of problems that you have a general idea of the unit circle. Okay, so when sine is equal to 1, that's going to be this point right here, which is going to be a pi halves. All right, now again, we're trying to, whenever we're dealing with triple angles or half angles or anything else, you want to find all the solutions, okay? So you don't worry about the restrictions of, you don't worry about your triple angle until the very, very end. So 3 theta is equal to a pi halves. Now, if I want to find all the solutions, how do I keep on getting the solution? I got to keep on going around and around and around, right? Which is going to be adding a 2 pi n. So you have to add 2 pi, or you could subtract 2 pi. That's why n represents any integer. So it's going to be plus a 2 pi n, where n represents any integer. Okay, then to solve for theta, now you can divide by 3 on both sides. So I'll divide by 3 on both sides. And then now I get my final answer of theta equals a pi over 6 plus a 2 pi n over 3. Whew, okay. So what about the next one? So this one says sine of 3 theta equals a negative 1/2. And so obviously when sine equals negative 1/2, we know it's in the third and the fourth quadrant. So that's going to be this point here and that point here. What exactly are these two angles? Well, I know halfway around a circle is pi, right? And I know sine is 1/2 at the pi over 6, which is the reference angle. So this is going to be pi over 6 over pi. So that'd be 7 pi over 6, right? So I can do 1 is going to be 3 theta equals a 7 pi over 6. And then now again, the problem is though, and actually if you look at this, 1/2, 7 pi over 6 thing, yeah. So 7 pi over 6. Now, immediately though, when I'm looking at this, I already wrote these two answers. Yeah, here and here. 7 pi over 6. I'm already starting to see the symmetry. Do you guys kind of see the symmetry between these? Doesn't it look like there's an even amount? Well, let's just finish this anyways. To get all the solutions, I'm going to have to add 2 pi n. And then divided by 3, divided by 3. So theta is equal to a 7 pi. Divided by 3 is the same thing as multiplying by 1/3. So that's going to be a 7 pi over 18 plus a 2 pi n divided by 3. And then over here, I would do the last one, which is going to be, what is this angle? Well, again, all the way around circle is 2 pi. But if I'm pi over 6, which is my reference angle, short, that's going to be 11 pi over 6. So then therefore I'd have a 3 theta equals a 11 pi over 6 plus a 2 pi n. And then again, divide by 3, and I get a theta is equal to an 11 pi over 18 plus a 2 pi n. All right. Now, RF, I have not gotten to your question yet because I think it's important to know how to get to this point, right? Because once you be able to identify those solutions, especially when you have restrictions or anything else, I think it's important. However, once you've graphed these points, and here's maybe the tips I would give you. Once you have these 3 points, if you see symmetry between them, then yeah, you're good, right? You know you can take this first point. Let's figure out what is the difference between these 2 points, right? So if I have a 7 pi over 6 minus a 1/2, now I did this from on there. I wonder if it's going to work in this case. So multiply by 3 over 3, 7 pi over 6 minus a 3 over 6, which is going to be a 4 over 6. That's going to be plus a 2/3, but I had that as a 2 pi over 9. Oh, divided by 3. Yeah. Okay. Yeah. Sorry about that. Yeah. Those are the answers before being divided by 3. So don't do that. Sorry. Okay. But I know, okay. So I'm looking at these points. Sorry. I was right in identifying symmetry. You see the symmetry, right? But everything got divided by 3. So crap, what is the new distance between these two? I know that they're going to be symmetrical. And if I divide all those angles by 3, they're still going to be symmetrical on that point. So what I need to do then is I need to determine what is the difference between these two. So I'll just pick 2 of them. What about we take an 11 pi over 18? You have to use the divided by 3 angle, not this original angle, right? Because these are not the answers. You had to take these answers, then divide it by 3. That's how you got your answer. So I'll do 11 pi over 3 minus a 7 pi over 3. Let's find the difference between these, or 7 pi over 18. And what you're going to get is a 4 pi over 18, which reduces to a 2 pi over 9. Okay, so that is going to be the equidistant between each of these angles from on there. And again, this is since they've been all divided by 3 in that case. And again, so now what you can do is that's what I would go through from on there. And then you can start with your smallest angle, which would be a right over here. So my final answer is theta equals a pi over 6 plus a 2 pi n over 9. And because that's going to be, I know, to the next point. And again, maybe you're like, I'm not really sure how that would 3 pi n over 9, and that would work in my case. So yeah, there we go. So hopefully that was a little bit helpful for you. Look for that symmetry. Once you know there's symmetry, then you can go ahead and use that as your simplified answer.